Hey guys, and welcome to another live stream. It has been some while since I've been live streaming the last time. Been pretty busy. I finished my masters now, so now I have more time to do live streams. Planning to do want to do live streams again, as I did like a couple of months ago. I really enjoyed having these live streams where I engage with you guys. In this live stream here, we're basically just going to like do Q&A, just throw whatever questions you have in the comments. We're just going to like do some researching. I'm going to scroll through like LinkedIn, going to take a look at some different resources, prepare some YouTube videos, and maybe also do a bit of coding. But yeah, mainly just researching, go over some different kind of things. Also, if you have some cool things that we can take a look at, definitely just throw it in the chat and we'll take a look. I think we should be live. Let me just go inside my YouTube here just to make sure that we are actually live. Can't really see my live stream on my computer here. Should be. Let me just see. Okay, so this was actually private. Let's just go in and make it public. So that's probably why no one is in here. Let me check. Should be live now. There we go. Now we should actually be live. I can see it on my own YouTube channel now. So yeah, let's just wait a couple minutes until people come in here, and let's just start. Like this video here, or like this live stream here, it's mainly going to be research, just some Q&A. So if you have any questions, throw them into like the chat room, and I'll basically like just answer all the questions. So we just do like a Q&A. We're going to take a look at some different like research. I'm going to prepare some YouTube videos and so on, scroll LinkedIn, try to see if we can find some nice resources, just go over some GitHub repositories, maybe do a bit of coding, but it's also up to you guys. If you have some cool things that we can take a look at, definitely just throw it in the chat, and then we'll just go from there. It has been some time since I've been live streaming the last time, but I really enjoy doing these live streams. Now I have more time to do them. I have been a bit busy like the last couple of months finishing my master thesis together with having like a full-time position, doing my YouTube still on the sideline, my online courses and so on. So yeah, there has been a lot of work. Now I'm back again to do some live streaming just to engage more with you guys. So yeah, again, just mainly just focusing on doing some research, just scrolling some cool things. This new repository here just came out from DCAI. It's actually like a pretty nice repository they created. It's something called like data gradients. I think it's used for like some data set analysis, computer vision data set analysis. So I'll basically just take a look at it. I think I found it here on LinkedIn. It should be like a Harpreet from DCI. I think he posted it. Something he has been working on. Hey guys, I'll just let me just drag the chat over here. Hey, oh, so you're facing an audio issue. Let me know if anyone else can't hear me. It looks like it's going through on my side. Let me just check on my own. So should not be a problem on my side. I can see my audio going through. Let me just verify on my own YouTube channel. My own YouTube channel now, so I can hear
Yeah,
myself. I
let's
can
just
hear
wait a couple
myself.
minutes.
So the audio should be good on my side, I think. Yeah. But let's just take a look. Let's just take a look here. Okay, so they actually like made some kind of like a report here that we can go through. It should be in the GitHub, right? Let me check. The report here. Report once the analysis is done. The parent. Okay, so this is basically just okay. So I think this is actually like just like you can do a data set analysis with this one, and then you can basically like extract the results as well. So that should be the case. Let me just check. That is actually like pretty cool. Let's go in and see their example notebook. So this was just recently released like an hour ago or something like that. So this is actually like pretty awesome. So let me see. Okay, so Data Gradient is an open source Python-based library specifically designed for computer vision dataset analysis. It automatically extracts features from your dataset and combines them into a single user-friendly report. Okay, that is actually like pretty cool. So you can. It sounds like you can just do like throw in your dataset. It does a lot of analysis, like statistical analysis, and then it's going to like just extract the features and the statistics, combine them into a single user-friendly report. So that's kind of also what they're showing here. Let's just make this full screen. So let's try to just go over like this report here to start with, and then we can always like jump back again. So yeah. So it basically just like generates a report, color distribution. So how the color distribution of the pixels are, like the pixel intensities for each individual channel are. Looks pretty nice as well. So it also explains what it is. So we both get like the color distribution, it explains what it is, and also why it's important. So that's very great. It looks pretty like simple, very nice. How's it calculated? Okay, so it also shows like how it's calculated, like the image brightness distribution. So you can see the average brightness of the images. So you can see like the range of the pixel intensities. So like the further we up here, like the brighter your images are. We can also do like history. It can actually be used to see if we can go in, or like if it's necessary to go in and actually like do some histogram equalization. So here we basically just have like this distribution, which is kind of like similar to image equalization. Image width and height distribution. So these are not like too complex image analysis methods, but maybe we get some more complex later on. Distribution of bounding box area. Okay, so that is actually like pretty useful. Depending on like what type of what type of data set you have. If you have like smaller objects, like larger objects. Also, if you have like objects at different like depths in your image, that will also impact this bounding box area factor. Here we can also see like how looks pretty nice that they also like explain why it's useful and what it is. And it seems like it isn't really like simple terms. So like distribution of bounding box area refers to the distribution of the bounding box area for each class in the dataset. The area is calculated as a percentage of the total image area. Okay, so yeah, again, it really depends on like the objects, like how far away are they away from the camera and so on. So I'm not really like too sure why it's so important. Any gaps in object size between your training and validation splits, which harm the model performance. Okay, so if you actually want to like train the model on detecting objects at specific like depths or like for different sizes, again, if you have a lot of objects that are larger in the training set compared to the validation set, it might not generalize as good. So yeah, it is actually like a useful case. So yeah, again, if you have any questions, just throw them in the chat. I'll try to explain, like I'll try to answer them and explain stuff. If you have some cool things that we can take a look at, definitely just to throw it over as well. So this live stream is mainly just for like doing some research. We go over like do some research for YouTube videos, just look at some of the new resources, We'll take a look at Hugging Face. It also looks pretty good with this report here now, so we might spend some time on that. So tell us, Yal, bro, I'm a student of Bachelor in Telecommunication System. I'm interested in learning AI machine learning. Can I learn these studies by my own, and from where do I have to start? Yeah, so basically, like on my YouTube channel, I actually have a lot of resources on my YouTube channel. It really depends on the area. So I actually get a lot of questions about like how people can get into AI, machine learning. I have some resources about that. Like I have some small like roadmaps. I also talk about it in some of the videos that are uploaded with like my YouTube journey. So in there you can actually like see how I did it, because I'm actually like I took a master's, like I just finished my master's in advanced robotics, so that was mainly like focusing on robotics. It was a bit of computer vision and also machine learning AI, but it was on the introductory level. So yeah, you can also like you can still branch out even though you're taking a degree in some specific field. You can still like branch out to whatever like interests you the most. So yeah, for sure, like you can choose like whatever you want to do. One of the good things about university, I spend a lot of university working on my own brand, my YouTube channel, branching out into AI, computer vision, and so on. So you will have a lot of time in the university when you're taking like your bachelor's and your master's and so on. So you can branch out, do whatever you want to do on the sideline as well, and just get into the field, and then maybe you get some new interest by just like looking around, trying to see different things, and also try out different things. It's always good to do that, for sure. So that was kind of like the path I took. Like if you want to get into machine learning, it really depends on the field. If you want to get in like to the computer vision side, natural language processing side with like audio, now also in the new transformer with the large language models and so on. But I have a lot of resources on my YouTube channel with computer vision stuff, AI, deep learning, like how can you actually like train models, how can you create models from scratch and so on. I have a whole deep learning playlist where we go over like everything from scratch and the basics, and then we kind of like just build on top of that. Right now, I'm more branching into actually like doing and just like exploring some of the newest research, both within like large language models, also computer vision and so on. So now we're basically just using all of it, trying to like stay up to date with the newest technologies and also how to use them. But the cool thing here about this report is that I think it just generates it like automatically. I'm not sure if it's just like the exact same parameters or like the exact same methods, statistical analysis that they're doing every time for whatever data set, or they actually like go inside like each individual data set and determine what are the best features for this specific data set and then generate the report based on that, or basically just like have a report structure and then just plug the data set into like some code base that you have, and then it just spits out a report like the same report every time, just with different graphs. So that might actually be the case, but we'll have to take a deeper look for that. I want to understand Game Alive on. I want to understand the theory behind machine learning, like how machine learning and its weight optimization works. Can you just suggest something? Yeah, so basically like for machine learning, deep learning, and so on, I actually like have the whole playlist. Let me just find it here, like since people are asking. So I actually have a playlist here where we go over all the basics from scratch in deep learning. Let me find it. There we go. There's actually like a lot of videos in here, but we go over a lot of the things that people are actually like asking for. So like introduction to deep learning. Some of these videos here are on the older side, but they're still very informative. My newest videos, like they're way better quality and so on, but like all the fear and those things, they still work. So yeah, I'm talking about like all the different kind of like part, like how we can create models from scratch, what are the different kind of like layers, architectures, and so on, and also how they work under the hood. So here, for example, like mastering optimizes loss functions and the learning rate, which is basically like how neural networks and just machine learning in general work if they're following like the gradient descent method. We talk about like overfitting, underfitting, how to train a neural network and make predictions, bias, weight initialization, trainable parameters, batch size, batch normalization, transfer learning, convolutional networks, pooling, padding. So yeah, I basically have like everything here, as you can see, like maximizing deep learning performance with MobileNet. So yeah, there's a lot of resources in here. I've used Keras and TensorFlow for this playlist here. Right now, I'm branching more into like PyTorch, but this is still really easy to work with. Like I definitely like suggest to go with like TensorFlow and Keras just to get used to actually like creating the architectures of the neural networks and so on, creating the training loop, just train the model, see how they work, tune some higher parameters and so on. Then you can always branch into PyTorch, where you can do like a lot more customizations and so on. So yeah, I have a pretty like comprehensive tutorial here that goes over like all the things. Like the latest part here, or like the most recent videos here is more like, it's not really the basics of the new of the machine learning and deep learning. I should probably like delete those videos from the playlist. Those are more like on the project side. But in the start here, I basically have all the theory to get started with the basics of machine learning and deep learning. I saw your SAM video. It helped to do a product before time. Thanks for that as well. Yeah, for sure, man. The new SAM model is pretty cool, and especially like the fast SAM model. I'm not sure which one of the videos that you saw, but I also just uploaded the live SAM model. So we're actually like running live SAM with this webcam here. It ran around like 8 frames per second, so still like fairly fast. We can some kind of like run it on a webcam now, even though like I'm using a 4090 RTX GPU, so that's a bit on the high side, but it is still significantly faster than the original SAM model, and we still get pretty good accuracy. So thank you so much. Of course, man. Of course. I want to know how much math I'll have to learn to get into AI and machine learning. So I was actually planning about doing a course, or like not a course, but like a playlist about what math do you actually want need to use to get into like machine learning, neural networks, and so on. Because it is not actually like a lot. It is more like it's more like the basic stuff. So you'll need to, the most important thing is linear algebra. So basically like how matrices, vectors, and all those different kind of things work, like how we can do different operations like matrix multiplication, dot products, and so on. So basically how we can do like linear algebra, how we can construct the matrices, how we multiply them together, like the sizes of them. You also like there's a lot of properties with matrices and also just linear algebra, especially when we're talking about like neural networks, scaling neural networks. In that part, there will be like a bit of math, and also if you use it for computer vision. So if you want to use like computer vision or like branch into computer vision, there's a bit more math in it compared to just like using AI models, training AI models, and so on. Because in computer vision, you have to do a lot of calculations with the camera parameters, finding depth in the image, also just doing like transformations from one image to another image, or if you want to transform points. But all of that is basically based on linear algebra. So that is probably like the most important thing. Even and then we also have like derivatives and so on. So that is probably like the most basic math that you need to learn to be able to get into AI and machine learning. But it's not really like complex math, of course. Like you will need some derivatives, some basic rules with that. So neural networks are trained with the chain rule, for example. There's also some different kind of like rules you will need to know, like what is the gradient, how do you calculate the gradient. But like all the things that you learn in school, like double integral, like triple integrals, like I've never used that before, and you're never going to do that in neural networks, machine learning, and so on. So there's not a lot of math that you need to do. I'm planning to do I'm planning to do a playlist going over the math. So basically just some basic operations about math, like vectors, like how we can also use that. So I also have I actually have a pretty good video here as well. So neural network from scratch, where I actually do a lot of the linear algebra and the calculations that you need to do to be able to create a neural network from scratch.
Hey guys, and welcome to the first video in this new.
So both have it here in C, I think, and then I think I have it in Python up here. So it really depends on like what you want to use, but it's actually pretty nice with the C library, or like just with C code, just plain C code. I think
so
this is in Python.
How fast I can create a neural network.
It is.
So
we're basically just calculating, like we do some different kind of like dot products here between the layers and all the weights, do some matrix multiplications, some basic linear algebra. We also do a bit of math, so we do some pretty nice tips and tricks here and there with the math, because we need to like calculate the derivative of our output. So when we're training like machine learning models, so just to give like a rough explanation of like how these models here are actually like optimized and trained is that we do like a forward pass with our data throughout the model. We throw the data through all the weights, we do all the calculations, so it's basically just like matrix multiplication, dot products, and so on, all the way to the final layer. Then when we're at the final layer, we would like to have a loss function. With that loss function, we take our ground truth. So if you're doing like supervised learning, we will have our ground truth. and then we basically take the loss with our ground truth, subtract that with the output that we get. So let's say that we want to predict like a dog, and we predict that it is actually like 8% sure that this is a dog, then we'll still have like a loss of 0.2. Then we use that loss to actually like just back propagate in the whole network again. So we just go from the last layer throughout all the layers back, and then we basically just do something called back propagation. So a forward pass, and then we do back propagation where we take the loss at the end, and then we actually just take the derivative of the loss with respect to each individual parameter and each individual weight throughout the whole network, and then we just pass it back, and that is back propagation. And the rule that we're using to actually back propagate the loss throughout all the weights in the network is basically the chain rule. And then when we're doing that, when we're basically updating all the weights throughout the layer, we will just like make some small tunings here and there until we achieve a loss, or like when we actually achieve a loss or like prediction that is exactly the same as our ground truth, then we have fine-tuned the parameters enough. So it's more like we have a loss, then we take a look at the loss, and then with math, with backpropagation, with the chain rule, derivatives, and so on, and gradients, we will just do some fine-tuning like a DJ. We just fine-tune like the music until we get like the perfect output.
We can just.
So yeah, these videos here are also pretty good for like getting into machine learning and so on, just to know like how these models actually implemented from scratch. You will learn a bit of math and also how to use NumPy. But I'm definitely planning to do a playlist with the basic math of how to get into computer vision, or like not computer vision, but AI and machine learning in general, because you can also use it in computer vision. It is a lot of matrix multiplication. You will need to know like what a transformation matrix is, rotation matrices, translation, like what are they actually like doing to the image, the points, and so on. I figured out this. I hope your mic isn't monotype. I couldn't hear it because of my headset. It should be. I think it should be in stereo. I'm basically just using the same settings as in my YouTube videos, so it should be. Do you have any updates on new models for real-time 3D object detection post-estimation? Thanks a lot for your work. So thank you, thanks a lot, man. So recently I've actually been using something called like the set camera. So it actually has a pretty good API. Let me just find it here. So this is actually like a really nice camera. It is also on the expensive side, but I have not seen like 3D object detection that is better out there in terms of in simplicity and also like the usability. So this is actually like a pretty nice camera, and we should be able to see an example here in just a second. Let me find it. Maybe not. Solutions. Let's get into the set UI. So I actually have the camera down here. I'm planning on doing some videos in the near future with this camera here. It is actually like pretty good. I think it's like $500 or something like that. So it's on the higher end, but it's also like a pretty crazy camera. So yeah, we can see that we can do like pretty good depth sensing, like 0.2. So it's basically like 20 centimeters accuracy, perception from 20 centimeter accuracy up to 20 meters. So this is actually like pretty good, and we still get pretty good accuracy at 20 meters. I haven't really seen like that many stereo cameras and depth cameras out there that can do up to 20 meters. So it's pretty cool. You can also do like 3D position tracking and mapping, and they have a really nice API and an SDK that you can just go in and use directly. So the best 3D object detection that I've seen, it actually goes in and tracks the objects as well. It runs fairly nice. If you're able to run it on a GPU, you can actually like run this on some kind of like Jetson Nano, but it also estimates or like calculates the velocity of each of the individual objects that you have detected. So it's basically doing 3D object detections, but it's based on 2D object detections. It is actually pretty cool, and it's I tried to use it on myself. Like I'm 1.86 meters high, and it estimated me to be like 1.9 meters. So it's actually like fairly accurate, and you can go in and train your own custom model. So you will train a 2D custom object detection model, and then you can throw the bounding boxes from those detections into this algorithm here, and then it will do the 3D object detection and tracking. So large scale 3D skeleton tracking. You can also like track your skeletons in 3D, as you can see here, because we have like the depth sensor. So here we can see that we actually get pretty good like skeleton tracking in 3D. So this can definitely be used for some chord analysis and stuff like that. Ignis Valorant, hey, it's been a while since I last came here. Yeah, welcome back, man. Welcome back. It's all been some time since I did the last live stream. I've had a lot going on. I just finished like my master thesis a couple of weeks ago. So I've been a bit busy because I both have like my master thesis. I have my YouTube channel. I have a full-time position as well, so I'm working full-time. I have my courses, YouTube channel, and so on. So there's been a lot of going on recently, but I have some more time now. I'm planning to do like a live stream or two every week, just to engage with you guys, do some research. So I'm mainly going to use the live streams here to like Q&As, just to engage with you guys, look at some cool stuff, maybe prepare some YouTube videos here and there, and basically just spend the time like that. Because I'm actually like doing this on my own, so it's just like, why don't I just like live stream this? I'm just sitting here like looking up different resources, doing some research, preparing some YouTube videos. I can just like live stream it and engage with you guys at the same time. So yeah, that's pretty cool. I was doing some computer vision problem on the internet and stumbled upon an interesting question. What kind of models would you use to predict missing pixels of an image? GAN, CNN, or convolutional LSTM? I'll like out of those three, I'll basically just go with like a CNN. I think like the CNN would be the best for that. But I think it depends on like what you mean by missing pixels. If it's just like dead pixels or like missing pixels in a frame. I haven't really seen like too many examples of that. Omar, you're asking like, could you please provide me with a roadmap or suggest a learning path to learn machine learning? Yeah, so there's a lot of people reaching out to me asking this question. So I'll definitely do a video in the near future where I'm going to explain like the path into machine learning, because it really depends on the area that you want to go into. I actually have a whole playlist. Let's just go over here again in case new people have dropped by. So I actually have a playlist with basically like all the basics about like machine learning, AI, and deep learning, how it works, like how you can set up a neural network, the optimization process, loss functions, training validation, how you can set up a training loop, batch sizes, and so on. So yeah, it is in there. You can go check it out. But I will definitely like create like a talking roadmap where I go over like different paths that you can take depending on if you want to get into the computer vision side, natural language processing side, like large language models and so on. So it really depends on your interest, your current state, and so on. But it is always good to like know some basics here from this playlist that I have. It is some older videos, but the information is still really good, and they're still valid. JR is asking, what is the depth sensor maximum sensing measurement? So are you talking about like the set camera here? So that is up to 20 meters, which is pretty good accuracy for a stereo camera. If you want to go like beyond that, you will definitely need some active sensing, unless you have some really good like some really good models that is trained, like for example like Tesla. They're doing depth sensing way far beyond 20 meters, and the accuracy is pretty cool as well. But they're kind of like stitching all the cameras around the car, doing this reconstruction, like 3D reconstruction of the whole world, and then they have like good depth sensing as well. So they're only using cameras, no active sensing. So Adam, you're asking like, hi, can you suggest me any tip how to develop like career in AI, CV, robotics? I also started STU, master in advanced work. Oh yeah, so we basically study the same thing. I just finished my master like a couple of weeks ago. It went pretty good. I was doing a master's in human brain interfaces, so that's not really like in the field of robotics as well. So it really depends. Like again, I took a robotics degree in our robotics degree. Most of it is actually like introduction to computer vision and AI, because that is also used a lot in robotics, but it is still on the introductory level, and there's actually like a lot of different courses. So I probably had like 3 or 4 courses just introduction to like neural networks. I don't know why, but again, just because you're taking one degree doesn't mean that you can branch out to like other things. I'll definitely like recommend you to do that, because you will have a lot of time in the university. You don't really need to like work 80 hours a week on what you're doing at the university. So you can branch out, but But yeah, like how to develop career in AI, CV, robotics. It really depends on like if you want to like do freelance work, if you want to. Depends on like if you want to work or just get into the field or just develop your knowledge base, skills, and so on inside of the field. So if you can clarify that, I'll definitely talk about it. About the missing pixels in an image, the pixels are just removed in a uniform pattern. So for example, each of the image is separated into blocks of equal sizes, and the 4 center pixels are removed. Yeah, so you can definitely use a convolutional neural network for that. But you'll still need to have like some kind of like prediction head on top of it to determine like where, unless you don't want to like detect the exact position. Yeah. Like a convolutional LSTM would more be like if you actually want to have like the time factor in as well, if it actually like depends on the missing pixels over time compared to just like a single image. Yeah. It's really awesome that you guys are just like throwing everything into the chat. It's really awesome. I like to just sit here and answer your questions and just engage with you guys. I know a lot of you guys have been following my channel for like a long time. I really appreciate that. Okay, so it was also like taking a look at the report here. Okay, so it actually looks like it does something specifically for your dataset, since they're calling it dataset adapters. My idea is that each of the pixels there has some sort of connection with the pixel before, so I was gonna try RNN, but I'm not sure if it's the correct approach. I think you should make it. I think you can make it work with just CNNs, because it will still be independent, like frame to frame, if you just want to detect like missing pixels. So how do I use my own custom dataset to do this? I might have an example for that as well. Dataset class names. So images and labels. So is this just for a classification? No, because they already had like the bounding boxes, so that's not only for classification. They also do it for segmentation here. What kind of post-processing can be used for this project? I'm segmenting a road and want to do post-processing on a segmented mask. I want to map the road, for example, turns, obstacles, and so on. So it really depends. Like it depends on like what type of model you're already using. So I know that like YOLO and those models, if you're using that for segmentation, they already do like the post-processing. I'm not sure like how much post-processing you can do. It will more be like at the intersection over union. you can probably also do some other refinement. But I think it really depends on like how your result looks. If you train a good model, it should give you a pretty good mask as well. So it really depends on like how your result looks. If it's like going like over the boundaries, if it has like holes in the segmentation mask, I can't really like imagine that. But yeah. By the way, how do you practice your programming skills prior to having a full-time job? Do you try to solve problems in Kaggle or maybe some other side? So yeah, that could be one possibility. That's not really like what I'm doing. So yeah, I have a full-time job. I'm doing like a lot of coding in my full-time job. So yeah, most of the code I'm writing is in my full-time job, and then I also do like coding for my YouTube videos, looking up new things and so on. So I'm not really like coding like that much, and more like doing research, trying out new stuff, trying to like put things together and so on. So it's not like full implementations. So I'm doing like the code base from scratch and so on. But yeah, that's usually like just how I that's how I practice my coding. So for some reason I actually want to practice my like C and C++ coding more again. There's just something with that language. Like I'm mainly like 95% of the time I'm just coding in Python now, because I'm doing like high level like research and so on, testing out training models, doing machine learning AI. So that's mainly in Python. But I really want to get into like C++ and C again, and maybe do some videos about that in the future, because there's just something cool with programming and coding in C and C++ for sure. So I hope to do some projects or like have some positions in the future where I'll need to like do some really low level code on C level and actually like play around with memory, maybe like some CUDA programming and so on as well. So yeah, I really hope to be able to do that at some point, but that's pretty hardcore as well. Let's just run this demo here and see like how the dataset structure looks like. It's probably easier to figure out how to use your own custom dataset after that. So here we're going to have our data loaders. Okay, we have a training split, validation split, create the data loaders. So it's just like basic towards data loaders. So when we have unzip this file here, we should be able to see like the format that we need our dataset to be in, and then we should probably be able to figure out how to use this on our own custom dataset. I might go in and do a video about this. It actually like looks pretty cool that you can just directly generate a report from that. So for sure. I'll for sure, because this can be used for a lot of things. Let's just see the results here. Preview of the PDF report. Image features, train images, 20 classes, class and use, annotations per image, medians, image resolution, smallest annotation, largest annotation. So we actually get some pretty nice statistics here, just directly. Like if you only need to plot in your data set, and then just run through like a notebook here, that is pretty awesome. I'll definitely create some videos about that. Okay, so let's see here, visualization of samples, segmentation features. So what does the segmentation features mean? Okay, so it's just like it's just visualizing like the images and the labels. So this is for a segmentation task. Object density. Okay, so this is pretty cool. Like here we can see the density of the objects in our training set and the validation set for different classes. So this is actually like pretty cool. Let me just zoom in here a bit so you guys can better see what's going on. Should be able to see it better now. So here we can see like if we want to detect a road, we can see like most of the road here, most of the road objects in our training set is actually like here in the middle, where it looks a bit different in the validation set. It will be a bit more distributed out because our validation set will be less. And I also think they only have like 10 images in the validation set, and the training set here we have 20. So it's probably not like the best visualization here. but it kind of like gives you an overview over like how does your training data look and how does your validation data look, and that can maybe explain if you're like overfitting, if your model is not really generalizing that good, and maybe also like for specific regions. So if you're only trained on like roads here and it couldn't detect like roads out here in the far back, that could maybe be explained by just taking a look at these object densities. Traffic signs here also looks pretty good. Sky, bus, vegetation, pole, wall. This is actually pretty nice, yeah. Also, we also have like class frequency, so how frequent all the classes are. We can take a look at that just to see like if we actually like need to train our model on more classes, or if we want to generate new data, what type of data should we actually generate more of. MATLAB is also good. It's easy to use, and we can visualize data easily. Yeah, for sure. Like I've also like used MATLAB a bit. I've mainly been using MATLAB in university, not really here on the sideline. I prefer to use Python for like doing most of my calculations and so on, because when I'm actually like doing the calculations and so on, I want to use them in a project. I want to use it in a Python project. I want to be able to connect it with different frameworks and so on. So yeah, I'll definitely like prefer Python for sure. The good thing about like MATLAB is that we're going to see the variables. It is easy to plot with. They also have a lot of different like libraries and packages that you can install and play around with. But I think like if I were to use MATLAB, I'll probably more use it for like, for example, like signal processing, and all those different kind of things, where like for machine learning, AI, and so on, I'll definitely go more for Python. We can also go in and use the new ChatGPT code interpreter that is also really good for like visualizing your data, visualizing results, and so on. Hey, I'm new to CV. I don't know whether this is a relevant question or not. What is the basic intuition behind like object detection and how it works? And what's the basic algorithm for object detection? So the most used algorithm for object detection is basically like the YOLO object detection. I have a lot of videos about that on my channel. I even like have a playlist where I try to just combine all the different kind of like videos that I have with the YOLO models. So we have like YOLO object detection models, and then I basically just go over all of it. We have like some YOLO v5, YOLO v6. We compare some of the models. Now we have YOLO v8 and also YOLO Nash. Use it for different kind of like applications and so on. But a quick explanation of object detection is that we basically just want to detect objects in the scene. So we will have a backbone, which is like a convolutional neural network. If we're talking about like the YOLO models, we also have some transformers now, some visual transformers in the backbone that also does a pretty good job. But the best models are basically using like convolutional layers as the backbone to extract features. So features and images, it can either be like, it can be colors, shapes. So basically like learns features, and then we have different kind of like layers, convolutional layers. So in the early layers, it learns more like coarse features, and then we basically just like go up in the layers, and then we will learn more fine features. So in the early layers, we might find like different kind of like structures. So we might find lines, angles, all those different kind of features. And then when we're going like further up in our convolutional layers, we might actually like go in and get some, like for example, like chairs, persons, some more like shapes, colors, and so on. So we'll extract more features or like more fine features in the last layers in our convolutional networks. And then you will have a head on top of that to actually like extract the location of that specific object in the scene. And then you can basically find like whatever object in the scene or like in the image that you want to detect. So you will have a backbone for extracting the features, and then you will have a head to actually like find the exact positions in the image. So that is the basic explanation about like how these object detection models work. I'm also a master student, but feels like my practical skills is kind of lacking. From when did you get into coding? So I actually I took a robotics degree. I got into coding like in the second semester or something like that. We started out with C++ programming. That was kind of like hurtful back then, but I really enjoyed it, and I also learned a ton about coding just from doing it in plain C++. I had some coding experience a bit before that. I've been coding a bit in assembly also, and also like C for embedded programming. So that's kind of like how I started out, and then we mainly did C++ for the first like 3, 4, 5 semesters in university. Then I started to branch out on my own into Python. I created my YouTube channel where I started in doing the coding as well. So that's mainly like how I got into coding. But you shouldn't be like too worried about getting like into coding like too late. It doesn't take like that long. It's more like you just need to put in the time, and sometimes you will just like sit for days and you can't really figure out like why your code doesn't work. And it's not really like wasted time. It will just be experience. So coding is all about like being experienced and just like being able to scroll through some code and just like see the error directly there because you have made the same error like so many times. So coding is all about like experience and just like thinking. It's basically just like logical thinking. It also depends on what type of coding you want to do. So if you're just like software engineering and so on, it is on a more like high level, where if you do like machine learning, AI, C, embedded programming and so on, it's more on the lower level, where you have to do like more calculations. You need to make sure that you actually like take into account like the memory. You have to a lot more things that you actually like need to just keep in mind. So it really depends on what you want to use. Like I've seen like software engineers that don't really know anything about like math, linear algebra. They don't even know like what a vector is, and I'm just like, how is it even possible to code without knowing like what a vector is and what like a matrix and how to use them? But yeah, again, like software engineering is something different if you're doing like front end or just like back end, setting up applications, web applications, and so on. It is a totally whole different world for sure. Interesting. I didn't know that every version of the YOLO isn't necessarily made by the same group. No, it's not. Like the most used YOLO models are for sure like the YOLO V5 and YOLO V8, and it is developed by Ultralytics. I'm actually like doing a YouTube video series with Ultralytics right now. Definitely go in and subscribe to them and give them a like, and also give them a view. So we actually like just uploaded this video today where I'm going to create a series with Ultralytics as well, where we go over how to use the YOLO V8 framework and the Ultralytics framework with their hub. They can also do like mobile object detection in real time. So that is pretty cool. They are the creators of YOLO V8 and also YOLO V5. You can do classification, object detection, object segmentation, tracking, and also post estimation with YOLO V8. And it runs very, very fast. So yeah. Do you know about like liquid neural networks? No, I've actually never heard that before. I'll just liquid neural networks. Let me search about it. Okay, that's actually like pretty. That's actually like pretty interesting. Because like traditionally neural networks, like they're just learning like during the training phase, and then with liquid neural networks, it can actually like change its parameters over time, so it's actually like able to learn over time. Okay, so that's actually like pretty interesting. I haven't heard about that before. I'll definitely take a look at it. I can see that there's like a TED talk here about it. Not a lot of resources. I might actually go in and take a look at that, because it's actually like pretty interesting that the models can change over time and adapt to specific situations. Again, as they mentioned here, like for signal processing, data that is changing over time. I've also done my master thesis on human brain interfaces, where we had some monkey brain recordings that I tried to do like classification on, performing different tasks. And the problem with human brain interfaces and machine brain interfaces in general is that there's so much noise and there's like so much variation from day to day in the brain, because like the brain is not really like a fixed thing. It is moving around all the time, so there's a lot of day-to-day variability in the brain. So let me just check. You're saying that you can only hear like sound from left AirPod. I'd be pretty sad if I had it in mono all the time, but let me just know if I have it in mono. It should be stereo channel, because this is just like the same settings that I'm using in my YouTube videos. But let me just check here on my side as well. It should be in stereo on my side as well. So right now it should be in mono. Right now it should be in stereo. Right now. Oh, so I made a mistake. Like you guys, you should remind me of that. So it should be in stereo now. just let me know. That's on my side. Let me just check. So right now with mono, yeah, now we're stereo. Yeah. Sorry for that. I'm really sorry for that. Now it sounds good. I'm sorry for that, guys. Hey Noel, hey Jason. Do you have any experience with any good smart camera systems? I've been using ESP32, but it's quite a slow smart camera. What kind of setup do you use, or do you like? So for smart camera systems like ESP32, is it even like able to run cameras? Let me just check. So isn't that like a really small sensor? Okay, so that's a like I've actually like worked with ESP32s before, not really with a camera. But it looks like you can get some like kind of like camera. I don't imagine it's good, but low power dual core 32-bit CPU for application processes. So I've not really worked with that before. Let me just ask a question. See your question. So I'm mainly working with like more like production cameras, videos and so on. So I'm like for most of my YouTube videos, I'm just using like a webcam just to show you guys like how it works on a live video stream. That can be transferred to like whatever camera that you have, or either like probably not like ESP. I can't imagine that you can like run AI models and so on, and that probably some basic image processing, maybe not even like processing. It will probably more be like extracting the camera frame from the ESP32 and then doing the processing somewhere else. So it's more like an edge device, just sending the images to some other device for processing. Also, I'm using like production cameras like as the set 2 here. I'm not sure like if you're familiar with that. I've shown it earlier here in the live stream. But I have this camera here. It is very, very awesome. It's a good stereo camera. I'm definitely going to create some YouTube videos about that in the near future. They also have a really nice API and SDK. So Ignis, you're asking like if you ever decide to put your thesis as a scientific paper, please let me know. So I'm not really like my supervisor actually like asked me if I want to if I actually want to like publish it in some scientific journal and actually like publish it out there. But I don't really want to do that. Not because I don't want to make it public, because I'm definitely going to create videos where I'd like do a walkthrough. I'm planning to do a couple of videos both with how can you create a master thesis. It actually like turned out pretty good. So how can you do a master thesis? How can you set it up? I'm going to like explain basically just to like how can you do a master thesis? How can you like choose a project? How can you find like a project that keeps you motivated over time? How can you plan your master thesis and so on? Also, so you have like a lot more time on the sideline to do different things, like branch out to different things. So I'm definitely going to do that, and then I'm just going to do like a video where I do like a walkthrough through my paper or like through my report, my master thesis report. Where I go over like the technical details, my considerations about it, the results that I've gotten, and also the architectures that I've been using. So I'm definitely planning to do some videos where I go over like the whole paper. The reason why I don't want to publish it is basically because like there's so many formalities out there. I have to put in a lot of work to like do some restructuring, actually like get it into a scientific paper and so on. And to be honest, I don't really want to like waste my time doing that. I'll just prefer to like create a YouTube video, walk it through. I'll just use it for you guys so you guys can learn from it, maybe get some inspiration for like how you can set up your own master thesis. Basically just to give you guys use it to give you guys like inspiration, and also just to motivate you guys, make the life easier for you guys compared to just like sending it out there in like the water. Like there's so many research papers coming out every day. It's not really anything that is just going to like boom and I'll get like 100,000 sites. So it's not going to be like that anyway. It's probably like a couple of sites here and there. So I don't really want to like put in the effort for that. It's not really like worth the time. Okay, thank you. I wanted to start object detection with machine learning at first and understand the math behind it. Could you suggest any resources? So I'll definitely recommend like my YouTube videos. I have those on like an overall level if you want to get into object detection. I also have my courses if you want to have some more like structure. So one of the problems with actually like starting out is that you don't really know like where to start, and also like how to structure it, how to find the correct resources and so on. So that's why I've made my courses where I basically go over like everything from scratch. I also recently got this recently just uploaded this research paper implementation course, which is really good if you're getting started with machine learning, AI, and so on. Because in there you're going to learn like how to read research papers, how to implement the model architecture. So we're going to have like the model architecture on one side, code on the other side. We're going to code everything from scratch. We're going to create some nice projects and so on in there. So I put in like hundreds of hours into this course here. It actually like turned out pretty good, and I'm actually like pretty proud about this course. If I had to like brag a bit about myself, so that's pretty good. I also have my object tracking course, which is also really good. I just have my YOLO v7 object detection course. It can be used with whatever YOLO model, but here we're basically going from like how can we get started with object detection, what is object detection, how can we create a data set, label your data set, do the training, how can we export it into our own custom Python script, do inference with different frameworks and so on. We cover that in those courses. And then we also have the tracking course where you go over all the theory behind object trackers, how we can track objects in the frame over time and so on. So yeah, I think we have some pretty good courses right now. I'm still working on some more courses that is going to be published in a couple of months. And basically like I'm actually like working on a course. I'll just announce that, but I'm actually like working on a course for like personal branding, like how to basically just like scale your career, how to get into personal branding, how we can do freelance work, how I did it, how we can branch out, because I know a lot of my viewers and so on, they're in university, they're students, they have some time on the sideline and so on, and just like to set yourself in a better position, because as I used to say that it doesn't really matter like how skilled you are or like how much knowledge you have, if you're not like visible to the world, it doesn't really like matter. So if I weren't on YouTube, if I weren't like developing and growing my own personal brand, I would probably just be like stuck here in my hometown. I'm based in Denmark, in a small city, like 300,000. The population is 300,000 people, so not really that much. I'll pretty much just be stuck here if I didn't have my like personal brand out there. Now where I can basically like work remotely from the whole world. Like I get a ton of offers every day. Like I have tons of offers for full-time positions, freelance work, and so on. I don't really have to like reach out to people, and I didn't really like spend that much time on the sideline doing my university degree. So it was definitely like worth it. But I really like I really like this, and I do actually recommend this research paper here. Not for the money or anything, but this is just like a really good skill to have, to be able to read research papers. Like how can you read research papers? How can you get through them like as fast as possible and get the most information? And how can you actually like use that information to your own advantage and actually like in code? So that is a very useful skill, and not a lot of people out there have the skill. So it is very useful, and this is mainly what I'm using like in my day-to-day full-time position. I learned a lot from your live stream. I appreciate your efforts. You're a great motivation for us. Thanks a lot, man. It's my pleasure. It's my pleasure being able to like sit here and engage with you guys. I really enjoy it. Like I've been doing this for like so many years now, like 3 years, something like that. And it's starting to like pay off as well. So I really enjoy it. I couldn't have done it without you guys, and I just really appreciate you guys supporting the channels. If it's just like liking the videos, subscribing to me, just following the videos, throwing comments in the YouTube videos. So also like if you have some comments during your videos, just throw them in there. Like I'm always like I'm pretty much like always on my phone. So I try to answer like most comments on my YouTube videos as well, also the old ones. So definitely just throw some comments out there, and and I'll most likely get back to you with an answer. Do you think that in the field of machine learning, paper publication matter for my career? I mean, like, would HR take that into account when hiring employees? So it really depends. it really depends on like your publications. They don't really matter unless you're like a really good researcher and has like thousands of citations and some really breakthrough research papers. Like if you just have like a couple of standard research papers without no citations from some random like university, they don't really care. And most positions, they don't really care about like research. They more care about like experience and projects that you have actually like done, and also just like real life experiences. If you want to get like some really hardcore research positions at Google, Facebook, Amazon, and those, it will probably make sense to have some great paper publications and so on. But in my opinion, your time would be spent like like better somewhere else for sure. Unless it's what you want to do. Like if you want to do like research, if you want to do papers and so on, like also like some people, they just really like that. They like to do really research papers, try out some new things, work on different projects here and there, and then also do publications, writing papers and so on. Some people like that. It's not really for me. I do more prefer to actually like create something for the real world. It's not like research is not getting out to the real world. It is just not you delivering it. You're delivering the research, and then someone else is using that to get it out in the real life. And I just like that more. So it really depends as well. But yeah, if you just want to get like a job, experience is the most important one. Just building a portfolio, having experience within different fields, and actually like have worked with the field that you're applying for. That will for sure help you the most. Yeah, experience and communication skills. That's for sure. You also need like you also need like a knowledge, but you can get away with like experience and knowledge. It's kind of like going hand in hand, but you can get away with a lot of things with communication skills and experience, and also just like experience. Basically, just having like a personal brand out there. We can just like go to my GitHub repository here or like my GitHub profile. So it's really good to like start building, like even though in university, start building some smaller projects, build a portfolio that you can actually like show. Create some visual things so you actually get out there. Create a LinkedIn profile. Try to grow your LinkedIn profile. Basically, just try to stand out from other people. Also, because like if you're applying for some position, people, they will go to your LinkedIn. They will go to your GitHub profile if you're like applying for like a coding position. So yeah, it's always just good to have something out there that people can actually go in and see. You can go in repositories. Okay, this person has worked with these kind of like repositories. They can even go in and see your code. Are you actually like creating some good code? How's your code structure and so on? And how are you organizing things? Then they will go into your GitHub or like your LinkedIn profile. Probably just take a look at your experiences on your LinkedIn profile. If you're active, maybe like what are your connections, your followers, what are you interested in. Basically just taking a look at your activity, your about section, experiences. Probably people would probably scroll down to that to start with, and then basically just see your experiences. What have you worked with? What has been like your main task to do in your positions. So yeah, this is probably like the easiest way to just get like a quick overview over like a person and how much experience that person has. Like you can basically just do it like in 10 seconds. You just go into like you just go into like LinkedIn. Here, pretty good profile, active on LinkedIn, followers, has some experience here. We're with CUDA, deep learning, computer vision, AI. Now we're going to GitHub. We go into repositories. He has 60 repositories. We go into the overview, some followers here and there. He has linking to different kind of like platforms that he's using. Look like well structured here. We can see the commits that he's using, a lot of contributions. Some stars here and there. He creates some nice projects. So he had probably good understanding, probably okay experience within like neural networks, AI, computer vision, robotics side, and so on. So this is like way better compared to if you just have like an empty profile. People would not know like your experience and so on. So yeah, that's also one of the reasons why I'm creating this new course, like how we can actually like brand yourself, how can you get out there, how can you actually like get offers. Because again, the more offers you get, like the higher salary, the more options you will also have. You don't have to like take the first job. Then I can basically like choose whatever I want to do. Like and find the position that suits me the best. I can also just work on my own, but I don't really want to do that. I'll rather just like find a job and then on the sideline work on my own, do the things that I like, but I don't want to just sit here and work by myself. I want to engage with people, work with smaller teams, do some research here and there, do some implementations, and actually like get something out there in the real life as well. So just trying to like figure out what works best for you guys, for sure. How to get into work as a beginner, due to the demand for experience. So again, like in every field, like it's pretty hard to get into. Into work as a beginner with no experience. So I'll definitely just recommend. Of course, you can get some positions, but you'll not be able to like choose between the positions. You will also get like a very low salary and so on, because again, like people are taking a bet on someone that is not really like visible out there. If you haven't done like any projects and so on, they're taking like a huge risk with you compared to like if you go into a GitHub repositories, there's a lot of code in there, a lot of experience. They can basically go to my YouTube and see like what is actually like going on. LinkedIn, okay, we can probably take a bet on this guy here because he actually like he has done something. So experience, it matters a lot. So if you don't have anything, I definitely recommend you to like start build some personal projects. It doesn't have to be, you don't have to like apply for positions where you have to like just work to do work. Like I have a lot of like a lot of my classmates or like a lot of my like the people that went to the same like classes and just in general when people go to university, people are just like, we are in the first semester, people are always talking about like, oh, I want to get internships, I want to work, like want to have like a school job, I want to like work on the sideline for some company. And it's just like you want to work for a company just for the sake of working for a company, but like what you're doing at the company, it doesn't really matter for your future path. It's just like, okay, I work with this company within this field, but it doesn't really matter because you haven't really done anything. So I know a lot of people like they're, just to make like an analogy, they're basically just like shredding papers. Like some people, they just hand them over like a stack of papers, go shred those, or like I want to like print this, or you can just sit here on your own, do something. So I don't really think that getting out to companies, getting experience through that, it doesn't really matter that much because you want to have the freedom to do whatever you want. You want to have the freedom to go out and create some cool projects. So find something that you're interested in. Just get out there, like create some personal projects with what you're interested in. It could be like basically like everything. Like if you're like, it could be basically like everything. Like if you're into horses, you can basically just like record a video of you riding on a horse, do object tracking, object detection, try to like do some image processing and so on. It can also be like if you're into sports, try to do some sports analysis with AI and machine learning. If you're into like music, you can also try to do some AI with music generation, some classification of music, maybe do a generation of music with AI. So it doesn't really matter like what you're into or like what your interests are. You can pretty much apply AI and deep learning and so on to everything. So just create some cool AI projects, create some AI cool personal projects that you wouldn't be able to do in companies. And that will gain you like a lot of experience because you will need to work with a lot of different things at the same time. I want to know about what the main thought process, the difference of building things between software engineer and AI machine learning engineers. So software engineering is completely different. So it's more like creating backends, creating like new features, like creating features in Google Sheets, Gmail, and all those different things, and doing the front end and so on, connecting databases. Where machine learning is more like training model that takes some kind of like input, trying to apply machine learning on like statistics, some analysis and so on. That will more be like integrated into some other features into the backend. So it's more like the machine learning engineers will do like the hardcore stuff under the hood, and then the software engineers will take over from there on a really like abstract level and try to like integrate that into like applications, web applications, and so on. So it's completely different. I have no experience. I have no idea about like how to do like the traditional software engineering, create web applications, and all those different things. Like I have no idea about any of that. I'm mainly doing computer vision, machine learning, some basic interfaces with like Streamlit and Python, so Python and so on, computer vision, so more like the hardcore low level programming research, implementation of machine learning model architectures and so on. So it's more like what machine learning and math and so on is to software engineering. It is what software engineering is to me as an AI engineer. Garen, lovely. I lately found your channel and I enjoyed through, though I still have a lot of my watch later because I recently started to study this field. I hope to see you in the live stream again to interact. Yeah, for sure, man. I'm planning. Thank you guys for watching. Like, I really appreciate it. I enjoy doing these live stream. I'll definitely do like a live stream like 1 to 2 times every week. Maybe just do like this live stream here is a bit longer. I'll probably like end it off in 5 minutes or so. But I'll try to like have a live stream, just 1 hour live stream, like once in a while. Maybe if you guys are interested, like also like when I'm just chilling, like maybe I'm playing some games here and there, I might actually just do some live streaming. We can go in and answer questions while playing some games if you guys are into that. Like I haven't really like played that many like video games lately, but once I was pretty good at Counter-Strike and also like League of Legends and so on. So like if any of you guys are like into that, I'll also like maybe do some live streaming, maybe just stream on Twitch instead. To separate it from my YouTube here, which is a bit more like coding tutorial side. Could also just do the live streams on YouTube here, but yeah, it really depends. As you just gave me a lot of inspiration to build my portfolio. Basically, my projects can be as simple as a machine learning model implementation. Yeah, for sure. Like you can definitely just create like machine learning model implementations as your projects and so on. Also, like if you take my courses, that will also be individual projects in itself. Even the research paper one here, you can basically just learn how to read research papers, implement the architectures, and then the implementation of those architectures. Like if you want to apply for a machine learning position, and you have implementations of research papers in your GitHub portfolio, it just shows that you know this field here on a very, very high level. So, or like on a very, very low level. So you're able to go in and extract like the smallest details, go in and do the matrix multiplications in a model architecture, like 8 layers into the architecture. So that is actually pretty hardcore. And I think a lot of people don't really have the skill here. It is a really desired skill. Also create this course here because I haven't really seen any resources out there like how to actually implement the research papers directly, like how can you read the research papers and how can you then directly implement it. So yeah, I think this research paper here, or like this course, is actually pretty good, and I would love to have it on my own when I started out. For sure. Because I've put in like a lot of time. I've spent like hundreds of hours reading research papers, doing the implementation myself. I would love to just like watch a course, like watch a couple of hours of video in a course, and then I will be able to do it. Of course, you will not be able to do it on your own, but you will be way better, and then you will like be able to go in and start doing it yourself to gain the experience. But I'm really happy that I gave you some inspiration to build your portfolio. That's basically like the main purpose of doing these live streams, and also just like throwing resources out there to you guys. So yeah, of course, like just building my own portfolio, building my own brand, and then also helping you guys to actually get out there, and I hope that I can just like help you in some way to make your life easier. If it's either with my videos. I actually even asked if I could record my master thesis, just to show you guys like how can you do the presentation, how is the actual setting inside like the exam room at a master thesis. So I'm really unfortunate that I couldn't do that. But I actually have like a day in a life video, which is kind of like, it's just kind of like an entertainment video. But I have this exam day in a life for my master thesis. Kind of like the whole setting, like how I prepare for my master thesis, how I prepare before going into exams, how I actually try to not be as nervous, how basically just like how a day in the life for me is when I'm going to an exam. It could be helpful for you guys, so that's why I did it. I would have loved to live stream, or like not live stream, but do a recording of a math thesis inside the like exam room, so you guys can see like me doing the presentation and then also answering like the questions and so on after that, because we had a 20-minute presentation and then we had like 30 minutes questions after that. So that's very unfortunate. I would have loved to show you guys that, because if it could have helped you guys, I wouldn't really care about like my grade at that exam. To be honest, if it could just, because like if I record that, throw it out on YouTube, if I could just help like 100,000 thousands of people actually like being better prepared for exams and just like be less nervous when you actually go to exams, because it is not really as bad as you think, then I will have love to do that for sure. That will probably be my best video. Do live stream on the weekend. Yeah, I'm planning to do that for sure. I have a lot going on also in the weekend. I work a lot, but if I'm doing like 2 live streams a week, it will probably be in the weekends, most likely on Sundays, because then I can start the live stream in the evening CEST time zone. So that will basically be like covering most of the whole world. So midnight, nice, Nico, great job with your channel. Accidentally found it, especially your way of expressing topics is great. Keep up the work, buddy. Thank you a lot, man. It means a lot to me. Like it means a lot when you guys are like writing those comments. It is very nice to see. Like I get a couple of comments like these every day, and it just like it kind of like makes my day. It's just like, okay, I pick up my phone, I can see a nice comment on my YouTube videos, and it kind of just makes my day. So it's hard to have a bad day when you get such nice comments. So I really appreciate you guys also for watching. But very interesting to watch your thesis defense. Yeah, for sure. Like it would have been pretty good. I have a video here where I show like my preparation and the presentation, and then I'm going to like do videos where I do a full walkthrough through the paper and try to give some tips and tricks on how you can create a master thesis. What are the topics I should start with and learn so I can build good AI machine learning projects? Yeah, so in the start of this live stream here, I basically talk about my playlist with deep learning, which actually covers a lot of it. So this is my my deep learning like neural networks introduction, where we go over like all the basic things with like layers, introduction to it, like how can you use like PyTorch, Keras, and TensorFlow, training, validation, test datasets, optimizers, loss function, overfitting, underfitting, realization, how we can train neural networks, how we can set up neural networks from scratch, and so on. So I went over that in earlier in this live stream. Yeah, thanks for watching, Ignis. It has been very nice. Thank you for being so active in the chat. I'll also like shut down the live stream here in 3 minutes. It's also like getting kind of late here. So yeah, thanks for watching, and have a great night. So I'll just see if some more questions comes up, or I'll probably just end the live stream here in a couple of minutes, and then I'll see you guys in a couple of days. I'll do 1 to 2 live streams every week. Now I have a bit more time compared to when I was doing my thesis together with my full-time position and so on. Play only up? What do you mean? Thank you. Just discovered your channel today. Going to explore it. Seems like you're doing great work. Yeah, thanks lots, Sutik. Really appreciate it, man. Really appreciate it. I hope you can learn a ton. Like again, if you have any questions, just throw them in the comment sections. I try to answer like most of the comments. I have my phone on me every day. I get notifications when people comment on the video, so I'm trying to answer all the questions in the comment sections in my videos. A super valuable 1.5 hour. It motivated me to never give up and keep work. Love you again. Like, I love you guys, man. I love you, man. It's my pleasure being able to help you out. I'm just happy, like if I can give you guys motivation just to go like one further step, like that is very valuable to me as well. That's kind of the reason why I'm doing this, for sure. It's one of the main reasons. So thank you. So yeah, I'll just drop the live stream here, and I hope to see you guys in one of the upcoming videos or in one of the upcoming live streams. So yeah, thanks for watching, and have a great day, guys. Bye.